Welcome to solverfy.
In this question, we have planetary gear A that is pinned at B. The link BC rotates clockwise with angular velocity 8 radian per second. Then the outer gear rack D is rotating counterclockwise with an angular velocity of 2 radians per second. We want to determine the angular velocity of gear A in this question. Okay, so one thing we need to recognize is that so this point, I'm going to call this point O. The speed at point O for gear A and gear D must be the same. Okay, because they are mesh. Gear A is meshed to gear D, so the speed at point O must be the same. Okay, so the tangential speed of the rim of gear A is equal to that of the outer gear. Okay. Okay, so based on the diagram, so we can calculate VO to be equal to omega D cross RCD. Okay, so for point O will just be it's just a simple R omega, or omega times R, which is 20 inch times 2 meaning omega D. Okay, so this is 40 I inches per second. Okay, and then if you look at this diagram, you can also see that VO for gear A, okay, for gear A, VO is VB plus omega A cross R, position of point O relative to B. Okay. Okay, so omega A is just the angular velocity of gear A. Okay, so okay, so in this case, we have 40 I is equal to VB. VB will just be using the length of link BC multiplied by the omega BC. Okay, so you just need to multiply 15 and 8. So 15 and 8, and you know that it's going to the negative I direction when it's rotating clockwise. And then omega A, you just make it rotating counterclockwise. Just assume it to be counterclockwise. And then ROB will just be 5J. Okay, so from relative to point B, point O will just be going down 5J. Okay, so minus 5J. Okay, so in this case, this is what we get. So for the I equals to minus 120 I plus 5 omega A I. Okay, so K cross minus J gives you I. So you can see that comparing components, okay, so 5 omega A is equal to 160, and then omega A will just be 32 radians per second. Okay, so this is the answer for this question.